Lesson 5 is investing into an account and putting regular payments in. Okay, so this you'll be using your graphing calculator, and you'll be using this function right here, apps, under apps. So once I hit apps, and it brings up, and you want number 1, financing, and then the TMB solver. Okay, and you'll see all this, and it means N is the number of compounds. So if you had monthly times 2, it'd be a 24. Interest is just your rate without the decimal. Present value or principal. Payments, and we always are going to negate those because it's something that's coming out of your pocket, not something positive that you have. Future value, and this is payments per year, compounds per year. And once you change one, these both go. And for this, we're just going to always leave it on the end, assuming that the payments are always made at the end, like at the end of a month. Okay? Okay, number 1. Her was invested 160 at the end of each month at 5.59 compounded monthly for 5 years. What's the future value? Okay, so we're going to go into our program. So N is 5 years times and compounding monthly. So I'm going to do that right in there. 5 times 12, 60. 5.59 is the interest. Okay, so we don't have anything at the start. And in our payments, he invests 160, so negative 160, and then that's what I want to know, and 12 is the compounds. So now you can see I'm going to press the solve button, so I'm going to have to hit alpha enter as I'm in there. So second enter, and it comes up as the future value. Okay, so if you want, you can have a second to look at the screen here. That's all the numbers that I would type in there. Okay, number 19. So we're going to do this again, this time 7 years. So we invest 160 each month. So I'm going to go up here and change my N. So compound it monthly for 7 years. Same interest rate, starting at $0. Payments per month is 160. Okay, monthly, still got that on 12. So I want to know this. So I'm going to go second solve. So the future value, and we get it at 16,402.74. So how much interest did he earn? That's the question now. Okay, so what did he put in is the question. He was putting in $160 every month for 7 years. So 160 times 12 times 7. This is how much money he put in. So that's the put in, and this is the end. So we're going to subtract. Okay, and we end up with $2962.74. Okay, deposits money every 6 months, 4.5 years into saving accounts, compounded semi-annually. He ended up with $12,000. How much did he deposit every 6 months? Okay, so we're going to go to our app. Okay, so we have, do we have the N? 4.5 years and compounded semi-annually. So 2 times 4.5. He ends up doing 9. Interest rate we have is 2.9. Okay, previous value is 0. Payments is what we want to know, and we ended up with 12,000. Okay, and payments per year is 2. Okay, so I'm going to go up to the payment. See my cursor. I'm going to hit second enter. Okay, and there's my answer. Every 6 months he would have to put in $1257.85. Okay, number 21, what interest rate compounded daily is required to make payments of $1 grow to $7.70 in 2 years? All right. So 2 years times 365, because we're compounding daily. Interest rate is what we don't know. Previous value is 0. Payments 1, but we need a -1, and we want to turn it. We want to turn the 0 into 770, and we're doing 365 payments per year. All right, here we go, up to the I, and second function. All right, there it is. So we need, the answer would be 5.3% interest rate would be what we would need. Okay, how long will it take for monthly payments of $145 to grow to more than $60,000 if the interest rate is 4.15 compounded monthly? Okay, so compounded monthly, got a 12 down there. The number is what we don't know. Interest rate 4.15. 0. Monthly payments -145. Future 60,000. Okay, I'm going to hit second solve on my N. 257. I'm going to write that down. Okay, but that's how many compounds. So I'm going to have to take that number and divide it by 12 because we were making 12 every year. And I get 21.44 years. Yeah, that's it.